Welcome to Unit 2, Lesson 22, Graphing Linear Inequalities in Two Variables, Part 2. The learning goal for today's lesson is to write inequalities in two variables and make sense of the solutions by reasoning and by graphing. We have three learning targets for today's lesson. Learning target number 1, given a two-variable inequality that represents a situation, I can interpret points in the coordinate plane and decide if they are solutions to the inequality. Learning target number 2, I can find the solutions to a two-variable inequality by using the graph of a related two-variable equation. And learning target number 3, I can write inequalities to describe the constraints in a situation. These are the three things you should pay attention to as we work through the practice problems. If at the end of the lesson you do not feel comfortable making one, two, or all of these statements, please use class time to ask for further clarification. Now we can begin the practice problems for Unit 2, Lesson 22, Graphing Linear Inequalities in Two Variables, Part 2. To qualify for a loan from a bank, the total in someone's checking and savings account together must be $500 or more. Which of these inequalities best represents this situation? If we see $500 or more, that means our total can be greater than 500 or equal to 500, but it could not be less than. So as we look through, the correct inequality is the bottom one. X plus y is greater than or equal to 500. Number 2, complete the graph so that it represents solutions to an inequality representing this situation. Be clear about whether you want to use a solid or dashed line. Now, greater than or equal to means we use a solid line. We can pick a point on either side of the line and test it. Again, the easiest point is the origin, 0, 0. If you tried to put 0, 0 in for x, y, then 0 plus 0 is not greater than or equal to 500. This means we would shade everything on the other side of the line. So everything on the top and to the right of the solid black line. So what we're doing here says everything in the shaded blue region makes the equation true because those combinations would make it more than $500. And we're saying everything on the black line itself because it's solid, makes the equation true because it would make it equal $500. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification before we move forward. The soccer team is selling bags of popcorn for $3 each and cups of lemonade for $2 each. To make a profit, they must collect a total of more than $120. Number 1. Write an inequality to represent the number of bags of popcorn sold, P, and the number of cups of lemonade sold, C, in order to make a profit. So, popcorn is $3 each, and it's represented by the letter P. Cups of lemonade are $2 each and represented by the letter C. And the total has to be more than $120. So for number 1, if I was to write this, it would be 3P to represent $3 times the number of bags of popcorn sold, plus 2C to represent $2 times the number of cups of lemonade sold. And because it needs to be more than, this is going to be greater than 120. So this is how you would take the word problem and turn it into an inequality. Number 2 wants us to graph the solution set to the inequality on the coordinate plane. So the inequality that we wrote is in standard form. The P and the C are on the same side. So because it is in standard form, we can use it to find the intercepts. First, we'll let C be 0. So 3P plus 2 times 0 is greater than 120. That means 3P must be greater than 120. The opposite of multiplying by 3 is dividing by 3. So we know that P must be greater than 40. So we can go to the P-axis and we can put a point at 40. Next, we'll do the opposite. We're going to let popcorn be 0, and we're going to solve for cups of lemonade. 3 times 0 is 0, so 2C must be greater than 120. The opposite of multiplying by 2 is dividing by 2. So C must be greater than 60. We go to the C-axis and we put a point right here at 60. Now, because it must be greater than, we're going to draw a dashed line connecting them. That way we do not include the values that make it equal to. Once we have our dashed line set, we can shade in our answer area. We know that if we try 0, 0, then 3 times 0 is 0, 2 times 0 is 0, and 0 plus 0 is 0, which is not greater than 120. So we do not want the area below and to the left of the line. We want the area above and to the right of the dashed line. Number 3. Explain how we could check if the boundary is included or excluded from the solution region. In order to do this, pick a point on the line. A point on the line that I could pick besides the intercepts at 0, 60 or at 40, 0 could be this point at 20, 30. If we substitute those numbers into the inequality, we have 3 times 20 plus 2 times 30 is greater than 120. 3 times 20 is 60. 2 times 30 is 60. And 60 plus 60 is 120. 120 is not greater than 120. Points on the line represent combinations that make the left side equal the right side. So we would not include it here because we only want the profit, which means it must be more than $120. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification before we move forward. Our next practice problem says, tickets to the aquarium are $11 for adults and $6 for children. An after-school program has a budget of $200 for a trip to the aquarium. If the boundary line in each graph represents the equation 11x plus 6y equals 200, which graph represents the cost constraint in this situation? So the key to understanding this one is this word right here, budget. Budget is the maximum amount you can spend. Anytime you see budget, it means less than or equal to. So because we see less than or equal to, less than or equal to means solid line. So that means A is wrong because it has a dashed line, and D is wrong because it has a dashed line. So we just need to know whether we should shade in the area under the solid line or above the solid line. So you take a point and check it. The easiest point is the origin, 0, 0. Well, if there are no adults and no children, that would mean no money. and 0 is less than 200. That means we want all the points under the solid black line. We do not want the points above. The points above would make us go over budget, spending more money than we have available. If you have any questions about how to solve this practice problem, please use class time now to ask for further clarification before we move forward. Our last practice problem says Tyler filled a small jar with quarters and dimes and donated it to his school's charity club. The club member receiving the jar asked, "Do you happen to know how much is in the jar?" Tyler said, "I know it's at least $8.50, but I don't know the exact amount." Write an inequality to represent the relationship between the number of dimes, D, the number of quarters, Q, and the dollar amount of the money in the jar. So, first we have dimes, and the number of dimes is going to be represented by D. Well, dimes are worth 10 cents, so we have 0.1 D. Next, we have quarters. The number of quarters is represented by Q, and quarters are 25 cents, so we have 0.25 times Q. And we know that Tyler said it's at least $850. The words "at least" tell us greater than or equal to. So we don't use equals, we use greater than or equal to 8.50, so that is $8.50. Number 2. Graph the solution set to the inequality and explain what a solution means in this situation. So, for number 2, if we had no dimes, then we would have 0.25Q is greater than or equal to 8.5. The opposite of multiplying by 0.25 is dividing by 0.25. This tells us that Q must be greater than or equal 8.5 divided by 0.25 is 34. So on our graph, we go to where there are no dimes and 34 quarters, and we put a point for our Q-intercept. Now we're going to do the opposite. If there were no quarters, we would have 0.1 D is greater than or equal to 8.5. The opposite of multiplying by 0.1 is dividing by 0.1 on both sides. This tells us that D must be greater than or equal to 8.5 divided by 0.1, which is 85. So we go to where Q equals 0 and D equals 85, and we put the other line, or the other point, for the D intercept. Now, this time we have greater than or equal to. This means a solid line. So we draw the line that connects the two intercepts and then we have to decide which side of the line is shaded. Because we know we want more than or equal to $8.50, if we tried 0 dimes and 0 quarters, we would have $0. So it cannot be the bottom side, it's gotta be the top side. So we shade in everything above and to the right of the solid line. This is telling us that every point on the line makes the equation true because it equals $8.50, and every point in the blue shaded area above the line makes it true because it's more than $8.50. Number 3. Suppose Tyler knew there are 25 dimes in the jar. Write an inequality that represents how many quarters could be in the jar. So all we need to do for this is take the original equation (0.1d), but instead of d, put 25. Now, we know that 0.1 times 25 would be 2.5. Next, the opposite of positive 2.5 would be minus 2.5. So we're going to subtract 2.5 from both sides to keep it equal. This will give us 0.25q is greater than or equal to 6. The opposite of multiplying by 0.25 is dividing by 0.25. So we're going to do that to both sides to keep it equal. This gives us q is greater than or equal to 24. So this tells us there would be at least 24 or more quarters in the jar. If you have any questions about how to solve any of the practice problems we did here in Lesson 22, please use class time to ask for further clarification before we move forward to Lesson 23.